right? So we're given this information about the density of the water is 1.24 kilograms per liter. We're asked to find out how many gallons this water would weigh. And we know there's 454 grams in 1 pound, and they tell us how many liters are in a gallon, right? So how would we start? Where would we start this problem? Yeah. Yeah, we know, okay, I've got, 1 gallon of water, right? And I recommend starting with the only number that's got 1 unit associated with it. So we know for every 1 gallon, right, 3.78541 liters. So yeah, step 1, we've got 3.78541 liters of this water. All right, now that we've got our volume in liters, what would the next step be? Yeah. Yeah, we could turn it to kilograms because now we can bring in density, right? We have liters. We're trying to go from volume to mass. Density, right, relates volume to mass. So the density tells us, right, after gallons canceled out, the density tells us, right, for every 1 liter, I'm going to have 1.24 kilograms of water. Bless you. All right, 3.78541 times 1.24. And I get something like 4.6939 kilograms, right? Now that I've got kilograms of water, so that was step 1. That was step 2, going from liters to kilograms, right? What would be step 3? Sure. Yeah, right. The last 2 steps would be kilograms to grams, because ultimately we're trying to find weight in pounds, and I know 454 grams per 1 pound. So, right, we know 1 kilogram is 1,000 grams. So kilograms cancel out and multiply by 1,000, we get 4,693.9 grams of water. And then the last step, right, step 4, we know we can go from grams to kilograms because we know, or grams to pounds, because we know for every 1 pound, I need to have 454 grams. So we're going to divide by 454 or 454 grams. And I get something like 10.339 pounds of water. Right, regular water weighs about 8 pounds per gallon. So this water that's got a lot of salt in it, that's more dense, weighs a bit more. So what would our significant figures be for this number? Yeah. Yeah, we'd go with 3 significant figures because we started with 1 gallon of water. 1.00 is 3 significant figures. So to 3 significant figures, right, we've got approximately 10.3 pounds, or in scientific notation, 1.03 e to the 1 pounds of water. Right, you're definitely going to have a dimensional analysis problem on the exam. It's not going to be this exact problem, but what we want to try to do is pay attention to what units we have, and then how can we relate those units to what we're looking for. We're starting with gallons. We didn't map it out. We're starting with gallons, right? And we want to go from gallons all the way to pounds, right? We did that by going from gallons to liters, liters using density to get kilograms, kilograms to grams, and then grams to pounds. So how can I connect those units that I want, given the conversion factors that we have in that problem? So I'm going to look for the conversion factor that relates those units. I want to go from gallons, right? I only have 1 conversion factor that has anything to do with gallons. It's gallons per liter. So that takes me to liters. I want to go to mass eventually from volume, right? I've only got 1 conversion factor that involves liters. So I can go to liters to kilograms, right? From there, it's the metric system to go to grams, and then the last conversion, grams to pounds, because ultimately we're looking for pounds of water. Any questions on that one?